In this video, we're going to take a look at another example of integration by parts. In this example, we want to integrate the function x to the 7th times the natural log of x. Okay, and so on this one, again, for integration by parts, right, we're going to pick u and dv, right? Remember the LIAT guidelines for picking u. It says that the L, right, comes first, and so generally you should pick logarithms to be or u, right? This is a logarithmic function, and then this is an algebraic function, right? A power function, which is also algebraic. So that means that I should pick the logarithmic function over the x to the 7th. And notice that's a little bit different than what we have done in the previous examples. In the previous examples, we had picked u to be the algebraic function because the other function was exponential or trigonometric, right? And that comes after the a, the t and the e come after the a in the LIAT guidelines. So there's our u, right, ln x. And then that would kind of force our dv to be x to the 7th dx. And again, just checking to make sure if I multiply my u and my dv together, I will get this entire integral right here. So that's good. Next up, calculate your du and your v, right? So for the du, I would take the derivative. The derivative of ln x is 1 over x, right? The derivative of u is just be 1, so I get du is 1 over x dx. And to calculate my v, I would integrate, right? So I would integrate 1 dv, that would be just v. And if I integrate x to the 7th, that's a power function, right? So I could use the power rule to integrate that. And when I do that, I get 1/8 x to the 8th. All right. And so now I'd go to the formula for integration by parts and make those substitutions. So here, u dv will be ln x and x to the 7th, which I just kind of wrote it in the normal order that you would write that. U is ln x, which I have here. V is 1/8 x to the 8th. Again, I kind of wrote it in the order that makes it look a little nicer. And then minus the integral of v, right? V is 1/8 x to the 8th, which I have here. And then du, right? Du was 1 over x dx. Right, so I wrote all that in there, and there it is again. What we want to do now is to simplify that. So what I'm going to do is pull this 1/8 out using the constant multiple rule, right? So I can pull that out, and then I have x to the 8th times 1 over x, right? That's going to be x to the 8th over x, which winds up to be x to the 7th. Okay. So I've simplified things as much as I can, and now I just need to perform this integral right here, which is an easy integral of a power function. I can just use the power rule. The antiderivative or indefinite integral of x to the 7th is 1/8 x to the 8th. Okay. All right. So next up, I am going to just simplify. Right, and don't forget to add the plus c. Here, all I really can do is multiply 1/8 times 1/8, and I get 1/64. And so that's the integral here, 1/8 x to the 8th times the natural log of x minus 1/64 x to the 8th plus c. And that's it.